Hello guys, welcome back to my channel. So in this video we are solving the fifth question of LeetCode series where we have to find the longest palindrome in uh, in a string. Okay, so you will be given a string and you have find the longest palindrome in that string. Okay, so it's similar to the question where we have to find the longest substring, but in this case there is a constraint. The substring should be uh, a palindrome. Okay, so if we see the example, this is the first string BABAD. In this string there are two palindromes, BAB and ABA. Both are of length 3, so both the answer is valid. Okay, in this second string you can see we are having only one palindrome with double B. Okay, so if suppose if you have any other string, something like ABA MA DAM. Okay, so in this we are having two palindromes. First one is ABA, which length 3, and second one is Madam of length 6, length 1 2 3 4 5, length 5. Okay, so Madam will be a valid answer because its length is more than this ABA. Okay, so to solve this problem, the correct approach is Mankus algorithm. You can find it on multiple videos. You can also ask the AIs to do that. And what that approach do, basically it finds the center. It's expand through each of the element and it finds a palindrome. Like from B it will try to expand. You can't expand from this B, so it will gives you 1. Then you have to expand from A, then you will get this BAB, then you have to expand from this B, so that we iterate through each element and we try to find the palindromes, and we update the center if we find the palindromes, and then we update the best length. uh, that's the algorithm, the Mankel algorithm. Okay, but for today's video, for sake of simplicity, I'm going to explain my own algorithm. uh, so how can you approach differently to this question? Okay, so let me explain my code and then we can see how we are going to approach this. So if you see, suppose this is our string and these are the indexes. What we are going to do, we will initialize I here. Okay, and there will be a left pointer. Okay, so at each step we are going to check, we will check if s of lp is equals I, where I not equal to LP. Okay, what does it means? Currently I and LP are same. Okay, so this will always return true because both of these are at the same position. Okay, so this will always return true, so we have to check that I not equal to LP. Okay, so we will move I in the next iteration here, and we will check the left pointer is here, so we will try to check if uh, A equal B, no, we will move forward. If A equal M, no, we will move forward. I will become here now. If A equals A, yes it is, and I not equal to LP, yes it is. Now we will check, is it a palindrome? No, it's not a palindrome, right? So we will skip this, we will just move forward. I will come here, again we will checking the same thing. I will come here, again we will checking same thing. Is this a palindrome? No, it's not. We will move forward. We will come till here, and then we will reinitialize I. So I will now come here, and we will shift LP plus 1. So our last pointer will become here, and we will start from here. Okay. So now we will check. I becomes here. I will check now. If M equals B, no, it's not. if m equals if b equals a, no it's not, it's b equal d, no it's not, then we will iterate this, then we will loop this, and we will come here. So now our left pointer will point here, and I we will reinitialize to this position. So if a equals m, no it's not, if d equals m, no it's not, if a equals m, no it's not, if m equals m, yes, m equal m. And now we will check if this is a palindrome. Yes, this is a palindrome, so we will push this palindrome in a set. Okay, so we will push this in a set. Now we will go next. So we will come here and we will just check whether there is any more palindromes in this uh, string is available or not. So we will go here, LP will become here, and I we will initialize. So we will check if I equal D, no it's not, sorry, if D equals A, no it's not, if A equals A, yes it is, and if this is a palindrome, yes this is a palindrome, add it to the set. So ADA will be added to the set, and so on we will move. Okay, so in this string basically we are having two substrings, and in last we will return the maximum length string in this set. So in this case we are having madam, so madam will be returned. Okay, so this is what we are going to do in the algorithm. Let's run the code stepwise. Okay, so we have initialized what we have done. We have initialized the left pointer I to zeros. We have taken a set, and now we are checking if our left pointer is less than this string length. It means less than here. Okay, yes it is. So we will go inside the loop, and we will run this loop until this LP comes till the end of a string. Okay, so we'll go inside, we will take the first character, first word, that is A, and we will check if w equal s and I not equal left pointer. Currently I is equal left pointer, so we will not check anything. We will move forward, and we will increment I. Okay, I equal to I plus 1. Now see, we have taken the next element, that is, so the next element in our string is, okay, it's not, okay, w equal to b, you can see here. Why it is not updating? There is a syntax mistake. Either you write w or you write s of I. Okay, so yeah, it has been updated. Okay, so as you can see, currently we are having the second character, that is b, and we are going to check if w equal to s of left pointer. So s of left pointer is currently a and w is b. No, it's not equal. We will move forward. We will increment I. Okay, so one string has been added. Similarly, we will add madam also, and that's how this algorithm basically works. So hope you understood this video. If you like this video, please subscribe and do comment in like how did you like this algorithm. It's not for code complexity or not for space complexity, it's another way of solving this. I was just explaining another approach to solve. Again, I'm saying the best approach is to solve this is the Mancos algorithm. Thank you, bye bye, see you in the next video.